Okay, when you do presentation, please talk to the mic because we're recording your voice as well. Okay. Yes.
Alright, we're going to talk about the implementation of the gravitational water vortex power plant. Our group is consisting of me, Muhammad, Cynthia, Wei, and Jia. Okay, what is the gravitational vortex power plant? It's a hydraulic power plant that harnesses the power of the gravity and natural vortex created by the flow of water. The first gravitational vortex power plant was built in Austria in the year 1965. The first successful test of the gravitational water vortex power plant in Nepal was carried out by a team of IU, which is the Institute of Engineering, in the year 2016. The advantages of the gravitational vortex power plant is that it can generate electricity from ultra-low hydraulic pressure. It's also environmental friendly and a renewable energy source. An example case of the gravitational vortex power plant is that it can be a technology. The technology can be the option for the electrification implemented in the flat regions of Nepal. The benefits of this option is that the future of the gravitational vortex power plant is promising, and it can improve the living standards for local people. It can also provide more opportunities for power plant researchers. For the location, it will be located in Songhai, Simalisau, Sarawak. The population of this place is around 70 households. The gravitational vortex power plant is suitable to be built at the low head area between 0.7 meters up to 3.0 meters at the flow rate up to 20 meters per second. It is better to be built up upstream at the Simalisau area.
This is a basic model of GWVP. GWVP basically consists of inlet and outlet canal, and the canal is connected to the basin. And inside the basin, there will be a turbine set, which consists of hub, blade, and shaft.
The GWVP is a green technology that uses renewable energy to generate electricity with low environmental impact and high efficiency. GWVP technology uses gravity and the power of water to generate electricity. It uses eddy current that create rotational motions which turn turbines and generate electricity. The design of GWVP is focused on providing stable and sufficient power. The proposed solution expected to provide enough stable energy for around 70 households in the area.
So we are going to use the dome-shaped basin. Based on the study, dome basin model helps to improve up the flow to 3.01%. This kind of shaped basin are more efficiency to create the electricity. And for the blades, we are going to use curved blade. Blade provided maximum efficiency of 21.363%, and the curved blade was recorded at 22.24%. The rate of rotation of turbine generated by the vortex is higher if we use curved blade.
The applicability of this project is high because GWVP can improve the living standard for the local and provide a stable and sufficient power for them. GWVP is also a cost-effective project because it uses the renewable energy and causes the low environmental impact. Regarding to repairs work, maintenance is very important to GWVP to ensure the working. For example, shafts or turbines, cylinders, and other components, as well as cleaning and repairs work. Maintenance works can be performed by trained personnel of the company or others local maintenance team.
Next part will be the cost. So this table shows all the material costs and the component costs and technical equipment to build up GWVPP. We are going to build up 2 GWVP, so all the costs are calculated in 2 sets. The total material cost will cost about 1,529,000 ringgit. And human resources. The table shows all the human resources that needed for our construction of GWVP and denote the cost to employ them. Human resources will cost about 1,172,000. This table shows the cost for other equipment and permit. Other equipment are needed to support the construction of GWP and is needed by the employer in the construction area. And it will cost about 112,000 and the permit will cost about 85,000. Maintenance are not included in the initial cost, but we have roughly reckoning down the annual maintenance cost, which is about 9,300 annually. So for the maintenance, inspection, and repairment, it will carry out annually, but the clean process for GWVPP will carry out every 3 months. This slide is about the profit and loss. So if we add up the 4 part of cost, the total initial cost is 2,898,000 ringgit. And the major cost is from the material, which occupied 53% from the total cost. And the human resources is the second major cost, is 40%, and other equipment and permit will occupy 4% and 3% each. To calculate the profit, we deducted the total cost from the total investment, and the value is 2,102,000 ringgit. About the return on investment, the ROI is 42% from the investment. Next part will be problem and solution.
Now I'd like to present about the problem and solution. The first problem that we face is the road access to the construction site. As you know, Sungai Singaraja is situated deep inside the jungle and is densely populated with diverse trees, and there's no road access from the entrance to the construction sites. And this poses a significant challenge that as we have to transport all the materials and the components of building GWVPP into the jungle. And the size of these components is also considerable, so we have to use the truck for the transportation purpose, and therefore construction a route is required for GWVPP project, as it can ease the overall construction process. And the solution to overcome the first problem is to hire a team of road workers to build the access route. To address with this challenge, we propose to hire a team of 30 skilled road workers to construct a sturdy road from the entrance to the site. And this road building project should commence at least 5 weeks before the construction begins. And by building the reliable routes, we can ensure the smooth and efficient of transporting all the materials and also the component of building GWVPP into the jungle. And the second problem that we face is the wild animals lose their habitat. As you know, jungle surrounding Sungai Singaraja is a home to numerous wild animals and that previously coexisted harmoniously before the construction starts. However, logging required for GWBP has resulted in habitat loss of some of these wild animals. And the solution for the second problem is to planting more trees to provide a new habitat. To mitigate the habitat loss, we propose to planting more trees in the area after the GWBP construction has been done. And planting more trees can also provide a comfortable habitat for the displaced wild animal and balance the ecosystem. Other than that, it can also reduce the rate of air pollution and improve the quality of air around Sungai Sinarjau. And the third problem that we face is the disapproval from the residents who living around Sungai Sinarjau. And a significant concern is that some of the residents living around Sungai Sinarjau, especially Aboriginal community, they may not support the GWBP project. This is because their lack of understanding about the GWBP project may lead to the opposition, and they may think the GWBP project may influence their way of life. And the solution to solve the third problem is to increase the awareness through public announcement. To address with this issue, it's crucial to raise public awareness and understanding about the GWBP project among the residents who living around Sungai Sinarjau, and we recommend to make an official announcement from the relevant authorities to provide a clear information about GWBP project, including project objective, benefits, and also potential impacts. By doing so, residents can gain a better understanding about the GWBP project, about the project purpose, and also the benefits to their communities. And in conclusion, in order to improve the quality of life of residents who living around Sungai Sinarjau, it's crucial to implement GWBP because it is a sustainable energy resource, and GWBP can fulfill the requirement of being stable and able to provide a sufficient energy continuously because it is a renewable energy resource, and implementation of GWBP at Sungai Sinarjau has achieved the initial purpose, which is provide a community service. And community services include more than just providing the local with convenience. Indirectly, it also provides long-term benefits, which is creating more job opportunities and decreasing the rate of unemployment. And by providing the community service, a positive public impression can be created. And this may lead to the sustainability of organization growth. And considering these benefits of GWBP for both the company and also the local communities, we propose that a plan for Persada Marine and Engineering Sdn Bhd to implement GWBP at Sungai Sinarjau.
Open up for Q&A session. Any question? Reference list? Thank you.
Okay, please click and share your screen in Microsoft Teams. Already submit to online one? Okay, that's fine. share it on Microsoft Teams first. Click the icon Microsoft Teams at the bottom. Bottom bar. There. Bottom bar. There's a Microsoft Teams icon. Yes. That one. Yes, click. Share. Share. Okay, Windows. Yes, your PowerPoint. Okay. Minimize the window for the Microsoft Teams.
So good afternoon. We are from ID Technologies, which is short for Innovation Engineering Technologies. And this is our company logo. I'm Liliana, and I'm the decision maker. Ethan is the person in charge. Xiao Tong is the accountant. Clotilda is the data analyst, and Phoebe is in charge of marketing. We were founded the early of March of 2013, and we're located in Jalan Ampang in KL. We have won 3 prestigious awards the past 3 years, and we have been accredited by SM and CIDB. This is our certificate. So about the project, GWVPP stands for Gravitational Water Vortex Power Plant, and it is a simple new technology. It utilizes the vortex's kinetic energy, and this kinetic energy propels the blades in exchange for electricity. So the first idea of this was developed by Franz Zottler in the 1970s, and it can be divided into 3 types, which is impoundment, diversion, and pump storage. So we chose diversion hydropower plant because the surrounding area of Sungai Setas is generally flat, and a successful example of a diversion hydropower plant is the Tasmania Hydroelectric Project in Alaska, which has installed capacity of 824 kilowatts. This is just pictures of the power plant in Alaska. So Sungai Setas is a small stream in Sarawak. It is located near a village called Kampung Setas, which has about 50 households. So Sungai Setas is about 3.4 kilometers long, and it generally rains almost every day. It has an elevation of about 37 meters high, and on usual days, the lowest temperature would be 20 degrees Celsius, the highest being 33 degrees Celsius. And the wind speeds range from 4 to 11 kilometers per hour.
Thank you, Elena. For the next part, we'll be talking about what's the project main purpose. So the main point of the project is to help the locals to generate electricity more efficient, as the locals mainly rely on generators instead, which can be costly in the long run. The next point is to establish more eco-friendly projects in the future. So to help with any of the pollutions or to slow down global warming effects. Here is a simple simulation of how the diversion power plant will work. So first, the water in the river will be split into 2 parts, which some will flow along the channel, and they will pass through a trash rack, which will prevent any large objects such as plastic or any trash from flowing in. This will eventually affect the machine, which will cause damage. So this trash rack is to help stop those trash from flowing in. After that, it will slowly accumulate in the 4-bay section, and it will gain velocity when it flows down and stop. This will help push the blades, which will then activate the generator and produce electricity. After that, the energy will be converted into the transformer, and the remaining water will just flow back out into the river. And this is how electricity will be generated to all of the locals there. Here is some technical information of how the power can be calculated using this formula here. So the electric power will be equals to the flow rate of the in the river or the pipe. We'll multiply with the density of the water, which is 1,000 kilograms per meter cube, and we'll multiply the acceleration of gravity, which is 9.81 meter per second cube, and the height where it falls down from. So the estimated maximum power produced in 1 month will be around 477,530 kilowatt per hour, which will be sufficient enough to supply all of the houses there, which is around 50 houses. Here is some design of the power plant, the materials they are made of. So for the trash rack, the aluminium trash rack and steel turbine and generator, they are all resistant to corrosion. They are long-lasting as they are made of some good quality of material. They are also strong and durable, and they are sold at a low cost, and they are also reliable, meaning low maintenance is required. Next, the cement will be used for most structures construction, which is because it is durable, strong, and also sustainable. It will not harm the environment too much. The aluminium power lines and transformer is used because it is lightweight, also it's cheap, and it's a good conductor of electricity. And for the maintenance of this power plant, regular inspection is required, and also cleaning of components will be held, just so to prevent any of the machines from actually breaking. So they will the people can instead find the chance to repair it before the component breaks down too badly, and we will spend more money to replace another one. Some of the major requirements can be the permits. So in order to establish a project, we will need to gain permission from the government or the landlord in order to build a land. So this is one of the requirements needed, and you also need to find a suitable water source. For example, you need to find a water source that will produce maximum energy while minimizing the damage that will be done to the environment. And also, social impact responsibility is needed, just the case of any sort of impacts that it might have on the environment. So we will need to take accountability to any of that. And lastly, we have the technical expertise and equipment, which is to help produce a more safe, reliable, and more efficient power plant. Our project goals, as mentioned before, our two main goals, to help the locals earn more of their income so that they could help to spend money on provide education for the kids, because they are currently lack of the money to do so. But with the help of this power plant, we are able to help to provide them the opportunity to go to school to learn. And it's also save and protect the polluted environment, which is becoming a big issue across the world, not just there. So this can help to prevent any serious pollution or destruction to the nature around. For the next part is the project.
Next part will be the information about costing, and this is the 5 costs that we need in our project of GWBBP, there will be the salary, material and equipment, indirect costs, technology costs, and other costs. In the salary, that consists of the security guard, secretary, project manager, quantity, survival, surveyor, safety officer, site engineer, construction worker, and a construction site supervisor. To build with the GWBBP, that consists of cement, concrete, transmission tower, turbine, generator, transformer, and the truss rack. And there will be the indirect cost of it, and consists of safety inspector, construction site inspector, and the land surveyor. And in the technology, we consist of CCTV and alarm to build inside around the GWBBP, and others will be provided for the worker. There will be the health insurance, transportation, food and accommodation, and some of the emergency costs. The total cost of our project GWBP are 3,530,108, and in the project we get profit of it, and this is the profit margin. The profit margin are important for the success for the project. It represents the percentage of revenue that remain after all expenses have been paid, and with a margin high is good for the company. And net profit margin vary by industry, but according to corporate finance institute, 20% and above is considered good for a company. Next will be the return of investment, and with a good profit margin allow company to cover their costs and generate a return on investment of the company. And it's same with the profit margin. If the profit margin is high, the return of investment high is good for the company. This is our summary of total cost, and the material and equipment occupied with the largest part of the cost, and others will consist of a small part of it.
Now I'm going to elaborate on the problems and solutions. So there are three problems that might arise during the construction of GWBP, which is the administration errors, noise complaints, and supplies expense overrun. So first off, administration errors. There might be unexpected delays during the construction process due to some sudden issues such as unfortunate injuries or technical difficulties that might require extra time to deal with. And we might also receive some noise complaints from the residents settling nearby the construction sites. This is understandable as our project requires a period of 7 months to be completed, and the noise level will definitely disturb the former peace of the residents. And thirdly, supplies expense overrun may occur as market pricings are constantly changing, and we cannot be sure that our suppliers won't change their budget offer. And these are the solutions that will help tackle the problems discussed previously. In order to overcome administration errors, we hired 5 construction site supervisors to conduct daily inspection of the construction site and make sure they inform the results to our project manager in order for him to keep track of the whole process. And if there are any unpredicted matter, our project manager will be sure to resolve it. And before the start of our construction, we will be announcing the operation of our upcoming project by posting up posters around the area, informing residents of the project. And we will also follow the construction time set by the government, which is from 8 a.m. to 6 p.m. on Monday to Saturday. And for the supplies expense overrun, we will try to negotiate with our suppliers and reach an agreement with them for relevant pricing. In order to do that, we will suggest signing a long-term contract with them in return for a more affordable pricing for them, since we will be doing future projects similar to GWVPP.
Moving on to the last part, conclusion. To sum up, the main idea of building GWVPP in this area is to help saving citizens earning and could have the chance to spend more on their daily item. Moreover, building a GWVPP can also improve polluted environment by providing a clean and renewable energy source. Other than that, it also provides numerous economic benefits to the community. It can create job opportunities, increase tourism, and enhance the region's infrastructure, thereby promoting economic growth and development. Furthermore, it also requires lessons learned that include challenges to overcome, best practices, and innovative solutions that bring advantage to future. The beginning date that can officially be used will be 7 months after construction begins. If the proposal of GWVPP for diversion hydropower plant is approved and accepted, the projected timeline here will be followed closely, so as not to cause any delay or extra cost if any interruption occur. In these 7 months, we will be having interviews with engineering, finance, and project director, and also arranging materials, excavate powerhouse area, and also install other like electrical equipment. And also installing CCTV and alarm to keep an eye on the GWVPP. In the 6 months, we will be confirm whether the hydropower plant is in good condition. The process of checking will be repeated again. The most important thing is to train the operation and maintenance personnel to ensure that they operate and maintain the hydropower plant efficiently. At the end of the 7th month, the diversion hydropower plant can be officially used. The reason to work with us was made possible by the fact that we only spent 3 million, where leaving 2 million available for the next GWVPP project that can have the chance to collaborate with us again. And this will also help other undeveloped areas in living better lives. We invite you to collaborate with us for long-term collaboration to build a brighter future for all. These are the references. Question.
In mind, if you do not use up all the 5 million, probability of you being accepted will be like half. They give you 5 million, you only use that much. It means that you're not fully utilizing. That is the, shall I say, the advice that I get from last year. Okay, yes, that folder please, number 3.
Okay, good afternoon, everyone. Today, our company will be presenting this project of gravitational water vortex power plant for Persada Marine for their corporate social responsibility. This is the rough outline for the slide. Okay, we're gonna talk a little bit about our company. The company was founded back in 2005 with a clear goal of industrialize and develop Sabah. Our team is filled with experienced professionals that have worked with using any eco-friendly means to develop Sabah. Our company is marketed over 200 million at Bursa Malaysia. We specialize in building power plant. We also have been awarded many prestigious awards, such as a Gold Key Award. Meet the team, myself as a board director. This is Chauncey, the manager. Zihong, the civil engineer. Hans, the lawyer. And Seng Kiat for our energy engineer for our power plant. Okay, I'll be handing out to Hans for the introduction.
So right now we're going to be talking about the introduction part, and we'll be introducing what is GWVPP, and we'll be talking about the location our project will be at. So to begin off, what is GWVPP? So GWVPP stands for Gravitational Water Vortex Power Plant, and it consists of a concrete basin with a central cylindrical column. And when water is poured into the basin through a nozzle, a vortex will be created. And when water flows down the central column, it turns a turbine located at the end, at the base of the column, and electricity will be generated. So the background of GWVPP, the idea of generating electricity using it was first proposed by the Austrian engineer Victor Schauberger, and the first one is built in roughly 1970 in Austria. There have been several successful implementation of GWVPP during the past years. And we have two examples right here. The first one is at Green School Bali by Turbulent Hydro. And the maximum capacity of that GWVPP is roughly 15 kilowatt, and it only takes up 63 meters square of space. The second one is built in Obergrafendorf in Austria by Zottler in around 2015. And it generates about 8.3 kilowatt of energy using the flow rate 0.9 meter cube per second. And that GWVPP can power up to 15 houses, and it's 63% efficient. Now let's talk about the location and background of our project, where our project will be. So our project will be based in Sungai Kolopis. It's a river in Sabah, East Malaysia, and that river flows through the district of Penempang, and it's located at the western coast of Sabah. The river is 25 kilometers inland, and that's the exact coordinate of the river. The elevation of the river is around 858 meters, which is approximately 2,815 feet, and the flow rate of the river is 2 meters cubed per second. Around the river, there's around 80 households living there, and the main economic activity there is farming, fishing, and local craft. And there is access to electricity right there, but the electricity cost is really high, so we plan to sell electricity at a low cost to help them. So the three main objective of our company is to improve local economy. So with electricity supply, the local can run their business until nighttime for a longer period of time, and it will improve their economy. And there's also more jobs opportunities. The second is to increase school productivity with technological advance, so school can run till later hours, and with electricity they can access the internet, and the education standard will be higher. And last but not least, to improve the quality of life for the villagers, as we sell electricity at a low cost, they can always use electricity when they want to. Now let's move on to the technical review.
Okay, so now I'll talk about the technical reviews of the GWVPP. First thing is the design of the turbine. So after some research, we found that the optimum design to generate the most electricity is that there should be 4 to 5 blades on the turbine. And then the blade angle should be curved at around 60 degrees. That means you take a flat plate and then you turn it 60 degrees. So it's like a curve shape. Yeah. And then the real turbine will be, the plate will be much thicker than what's shown on this diagram. And it will be made by aluminium. So why aluminium? First thing is that aluminium won't rust, and also it's very lightweight and durable. So next one, we have a design of the GWVPP itself. So here we have a side view of it. So the turbine, to achieve the maximum efficiency, the turbine should be positioned at around 65 to 75% of the whole height of the GWVPP. And then the runner height, which means how tall the turbine is, should be around 30% of the whole height. And then the exit hole for the GWVPP should be a conical shape and not a cylindrical shape. And then this is the top view. So looking at it from the top, the diameter of the exit hole for the water should be 20% of the diameter of the basin. And the water inlet, where the water is coming in from, should be small. So this is the design of power plant. Very good blueprint. So that's the river itself. And then we plan to build 3 GWVPP on the land beside it. So first the water will be redirected in. It will spin the first turbine, it will leave it, spin the second turbine, leave it, spin the third turbine, and then leave and join back into the river. So there's a trash rack at the start of the canal. That thing is used to filter out the big, large debris, like maybe a log fall into a river. So the trash rack will protect the GWVPP from large debris. There's also a sluice gate. A sluice gate basically is a gate that can be lowered down to reduce the volume of the flow rate of the water. So our turbine is the capacity is 15 kilowatt. And then the research shows that ours will be around 80% efficient, so 20% of energy is lost. So that means it will generate 12 kilowatt per second, 12 kilojoules per second. So that means for each turbine, every year it will generate 105,120 kilowatt hour. So for 3 turbines in total, there will be 315,000 and 360 kilowatt hour. And now I'll pass it on to Sangkiat to talk about the suitability.
First of all, the energy produced by GWVPP is renewable due to its energy generated through momentum of water. So there will be no production of greenhouse gases, which therefore prevent air pollution. Secondly, less operation cost, as GWVPP doesn't need to be checked on every day. It just needs to be checked on periodically, and it doesn't require huge manpower to look after it. And finally, it is eco-friendly, as it requires less space to build compared to something like solar panel, and while also not causing disruption in ecosystem like building dams. And most importantly, it is not noisy due to the only noise it makes is the flow of the water, which has less noise pollution. We'll be checking on the turbine each half of a year by our energy engineer. The cost will be low, as there will be no salary cost, as it was included in his job. And the only cost we'll be paying is the cost of changing components and transportation. Now let's move on to the timeline and financials. We expect our project to be done in around 1.5 years. So starting on 1st day of January, we'll be sorting out legal issues, drawing blueprints, and purchasing materials. We'll start to install metal fences and landscaping from 1st day of February to 1st day of December. At 2nd day of January, we'll start our construction, where we're starting to pour our concrete to build basins and use wood for scaffolding. At 2nd day of April, turbine and generator will be installed, and this will complete our construction. We'll make a test run of the GWVPP around May of 2nd year, and if there's no issue discovered throughout the test run, we'll consider our project to be complete. Here is the table of our financial costs. So for the salary, for the workers, we'll be employing talented architect and landscaper
We will also employ workers in the local to provide them job opportunities. The total cost will cost around 1 million. For material, we'll be buying metal fence for defense purpose, concrete for building basin, trash rack for refueling debris, wood plank for scaffolding and steel beam to hold the GWVB in place. This will cost around 30,000 and 30,000. For the equipment, the turbine blade will be cost around 780,000 for 3 turbine blades, and 2 million for power storage box, 9,600 for AC generator, 500-volt power cable for connecting the electricity to the generator, and utility pole for 440. The total cost will be around 2.8 million. And for the indirect cost, we will spend 45,000 for transportation, as we'll be renting truck services to transport our materials. We'll also conduct training for the workers, which we will spend around 2,400. And last but not least, for the emergency cost, we'll spend around 500,000 for emergencies. So if we add up all the total costs, it will be around 4.4 million. For revenue, we'll spend around 4.47 thousand for electricities, and we will spend around 38,000 for workers, and we'll gain around 11,000 for profit, which will have return on investment of 0.2% or 0.2%. Now I'll pass the time to my manager, Sean.
Okay, now moving on to the problems that could arise from building this GWVPP. Okay, so the first problem would be sedimentation and erosion. This problem is because there's fast running of water from entering the vortex chamber, which will cause damage to our power plant and reduce the efficiency. And then the second problem would be construction and infrastructure. As we know, building the plant requires some major construction efforts. And depending on the scale and complexity, this would lead to delays or cost overruns. And for the last problem, we found that this area is known for their heavy rainfall season. So therefore, this place would be prone to flooding. So the first problem, our solution would be that we have regular maintenance around the vortex chamber. And then addition to that, we have monitoring of the downstream riverbed and sediment transport. This will detect any erosion and sedimentation issues. And if large amount of erosion is detected, we will close the sluice gate and later take further prevention. And for the second problem, construction and infrastructure, as I said just now, delays, cost overruns, and logistical challenges. And because this place is at a mountain area and kind of rocky, so it will be hard to landscape. So our proposed solution would be hiring more workers and using heavy equipment such as tractor and crane. Yeah, and then for unforeseen circumstances, we would have emergency funds beforehand to prepare that, and so we would have a longer time to work on. And if worst comes to worst, we would have an erosion control blanket. And for the last problem, flooding. As I said, this area is prone to flooding. Sluice gates will be installed to control the water flow and prevent damage of equipment from unwanted trash. And it will have an elevated design to protect the major components of the power plant in case they get damaged, to prevent them to get damaged from the flood water. And also lastly, we have an additional power storage box, just in case the first one gets damaged from flooding. And now comes to our summary. And our summary would include the benefits and why you would want to pick us. For the benefits, this power plant is a renewable energy, and that after construction, the day-to-day expenses will be less, as it will be an automated machine once it's constructed. And then this is also eco-friendly. Cost of electricity will be reduced, and we will bring back some benefits to the locals, as the locals, if we hire them, we're providing job opportunities to them. And how can our clients benefit from this? They would demonstrate their commitment towards to environmental sustainability by investing in us, and that will be viewed as a company that supports renewable and sustainable technology, and later enhance their company's reputation. So why do our client wants to pick us? At HCNY, we believe in giving 110%. By using our next generation data construction, we help organizations manage agile workflows. We thrive because of our market knowledge and great team behind our product. As our CEO says, efficiencies will come from proactively transforming how we do business. And this is our reference list. And thank you. Any questions?
Girl, go stand aside. Okay. Good afternoon, everybody. We are the. Whoa. Oh, okay. Okay. Wait. Okay. I don't know what I'm doing. I just got here. Okay, come in some slack.
Okay.
I'll see the screen.
Good afternoon, everybody. We are the representatives from Hydro Green Construction. Today we'll be talking about our project Sungai Setas. So as a brief introduction, from Hydro Green, we have 26 years of experience under us. We achieved the Green Tech Awards in 2020, and we specialize specifically in hydropower and advocate the use of renewable energy and green technology. Our achievements include the power plant in West Kalimantan, as well as some work in Thailand and Kanchanaburi. We were also involved in the construction of the large-scale dam in the Yangtze River in China. As well as this, we worked in Cambodia and Australia with the AGL Energy Company to work on their respective construction of their power plants. Now, why would you choose the GWVPP over other conventional sources of renewable energy in hydropower? Well, the GWVPP is cost efficient and is typically established in rural areas, something that is important to us because rural areas typically don't fall under the power grid construction of their respective governments. The example model we have based our plans on are the GWVPPs located in Kathmandu, Nepal, due to the similar dimensions of the rivers that they were constructed there.
Okay, for the location, we propose Sungai Setas as our construction site of the GWVPP. as we could see in the map. Sungai Setas is located at Sarikei, Sarawak, Malaysia, and we are going to build 2 GWPPs for 50 households and 1 social center, which is equivalent to 11,000 kilowatt hours of electricity per month. Since there are 2 waterfalls in the surrounding area of the Sungai Setas. And as I said, Sungai Setas is situated near 2 flowing waterfalls, and these pictures are taken from our specialized simulation program. Wow. The red arrows is the waterfalls, and the blue arrows is the water of the stream. And this is the first waterfall, and this is our second waterfall. Our GWPP will be located at around here and here. Based on our research, the depth and the length and also the width of our river is estimated around 3 meter, 3.4 kilometer, and 19 meter respectively. So this slide shows the weather and the nature of landscape of Sungai Setas. This graph is the weather forecast at Sungai Setas, and it shows that it has high average rainfall in that area at around 80 millimeters of precipitation every day. The picture below is the topography of the surrounding area in Sungai Setas. The blue color part is the is the land below the sea level, and as the frequency of the color gets higher, the height of the land gets taller. And since the Sungai Setas is located at the tropical rainforest, it has uneven terrain and also dense forest, and this could pose challenges to our project. These are the challenges of our project. First of all, natural disasters such as flash floods and landslides is very common in that area due to high rainfall. And secondly, uneven terrain will cause our heavy load vehicles such as excavators, trucks, and also bulldozers hard to traverse on. We have figured out some solution for our challenges. First of all, we would avoid the extreme weather by planning the schedule based on the weather forecast. Secondly, we will map out suitable trails for the heavy vehicles by surveying the surrounding of the project site. And we have references to the project in Nepal since the land conditions are similar.
This is a process overview, and I will be giving you a brief demonstration on the component of the GWBBP. First, we will start with the inlet, into the canal, into the round basin, into the cone, and lastly the outlet. For the mechanical parts of the GWBBP, we have the turbine shaft, turbine blades, and lastly the turbine part, which is mostly made out of aluminium. Using a specific simulation program, we were able to replicate a 3D model of the GWBBP. Here we propose the round basin diameter of 2 meters and a canal length of 7 meters. Here is going to happen. Using that blue arrow to represent the water flow from the waterfall, the water will enter from the inlet into the canal and into the basin. Once it enters the basin, the water will flow in a circular manner that mimics a whirlpool, or also known as a vortex, hence giving its name, Gravitational Water Vortex Power Plant. Speaking of gravity, the gravitational potential energy of the water flow will then be converted into kinetic energy once it touches the turbine blades. The turbine blades will start to rotate in a fast rate that converts the kinetic energy into electrical energy. Yet technically, turbine blades itself cannot convert kinetic energy into electrical energy itself. Hence, we will implement a generator at the top of the shaft. And once that happens, electricity can be produced to the people of Sungai Setas. And once the water has done its job turning the turbine blades, the water will spiral downwards down to the rear part of the GWBBP and exit via the outlet back to nature, back to the stream itself.
Okay, this will be our timeline for the construction. we will take about 5 months to finish the GWPP process. Okay, in the first week, we will interview lawyer to speed up the application process of permit. And week number 2 to week number 5, we will obtain land cleaning, construction, and logging permit. We hope that we can get the permit in 3 weeks' time with the help of the lawyer. If not, we still have enough time for the upcoming construction. In the week 6 and week 7, we will start to interview subcontractors, architect, and building maintenance technician. And week 8, we will start to sign contract with those interviews that we choose for the construction. After that, week number 9, we will start to order the materials and start to being landscape and install the workers camp. This will take 2 weeks time. And after finishing order the materials, we will start to install the communication lines for software monitoring and electric cables for worker camps for them to have electricity. And at the 12th and 13th week, we will start to construct the GWPP number 1, and 14th and 15th week, we will start to construct GWPP number 2. It will take about 2 weeks for us to finish it. And week number 16 and 17, we will install all the electric cables for GWPP number 1 and GWPP number 2 in order to conduct electricity properly. And week number 18, we will check everything and test for the do tests for the GWPP number 1 and number 2 in order to make sure it is safety. Okay, and at the last week, which is week number 19, if the GWPP is tested and run properly, and we will start to operate and let the GWPP conduct electricity.
Next will be our estimated cost for this project. So we split it into 5 initial costs, which is renovations, raw materials, technology/machinery, miscellaneous, and labors. In renovations, we're paying for the contractor, subcontractor, the one that we're hiring outside of our company. Then for raw materials, just purchasing our concrete, technology/machinery, so the items needed to build the GWPP. The miscellaneous is the fuel cost. Diesel is for our excavator, bulldozers, tractors, and labor is just to pay. And then the total cost will accumulate to 2.4 million, and with the remaining 1.5 million, will be doing for emergency funds and maintenance. So this is our balance sheets for 2 previous years before. So we have total assets of 7.2 million in 2021 and 7.9 million in 2022. And the liabilities, we have account payables, accrued wages, accrued compensation. And next is our income statement, which shows about our financial statement to show our expenses and our expenditures. And it shows whether we are making profit or not. So you can see our net income for 2022 and 2021 was 26 million on 2022 and 20 million on 2021.
Now, why choose hydrogreen construction? We as a company have long since advocated for green technology, but considering the appalling discussions around climate change, we have since decided that this would be our passion and that we would work harder towards using our assets in hydropower to make the world a better place, as well as provide for communities that are disenfranchised due to displacement from climate change. Now, from the representatives of Hydro Green, the Chief Executive Officer, our Finance Supervisor, our Workers Welfare Officer, our contractor, and our technician, we thank you for listening to our proposal. Thank you very much. No question. Okay, got it. Wait. What do I do now? Please press. Oh, just press.
Go to Teams. Okay. This one? No, this one. Big one. Share. Extinction. Which one? This. I don't know. Where is it? PowerPoint Live. Which one is this?
No, I think you go. Yeah, click this window.
Oh, this one. Yeah. There we go. Okay, cool. And then afterward. Minimize. This no.
Yeah. And then present this thing. Good afternoon, investors. Good afternoon, audience. Thank you all for coming today to give us both your time and your attention for us to present to you a project we are extremely proud of. We are 5 representatives selected specifically by the board, the executive board of Vortex, to convince you today to invest in us. However, I'm sure by the end of this presentation, you won't need much persuasion once you see what we have to offer. So without any further ado, I introduce to you Project Ding Ding. Like I mentioned before, a project we work tirelessly and effortlessly on day and night to finalize and present to you today. So we start off with what the project is. Let's look at what we'll be presenting to you and how we'll be going about it today. So firstly, we're going to give you a brief history of our company and a general overview about us. So moving on, we'll move on to the background and current state of the GWVPP, followed by the suitability and maintenance, the problems and solutions, followed by the budget, the profit and loss, the return of investment, and why you should choose Vortex. So, who are these 5 people that stand before you today? Well, meet our team. Firstly, we have...
I'm Scott. I'm the architect for Vortex, and I help design most of the infrastructure for this project.
Hi, I'm Tane, and I'm the construction manager for this project. My job is to essentially oversee everything that happens on the construction site, and I report directly to the executive board of Vortex so that they can update you, the investors, on exactly what's going on, and you don't have to, so that you don't have to raise a finger and can watch everything happen right in front of your eyes. Moving on, we have Xiang. Now, unfortunately, due to Xiang's tireless commitment and effort and dedication to this project and having to talk to hundreds of people to get this project through, he has unfortunately lost his voice today. However, fear not, I will be explaining his role on his behalf. So Xiang is our lead civil engineer, and his job is to essentially design and supervise the construction of the dam and the waterways that flow around our GWVPP. Moving on, we have...
Hello, my name is Chen Hao, and I'm the lead accountant for this project. I'm responsible for checking and tracking all the project's finances.
Everyone, I'm Go Mohammed, and I'm the lead electrician for Project Ding Ding.
Now they in charge of implementing all electrical systems and making sure they work correctly throughout the lifetime of the GWVPP.
What is Vortex? What is this company that stands before you today? Well, we were a company that was founded in 2006. And like most firms out there, we started off small, but we had the drive and the ambition to make it big. We specialized in creating heat pumps and heat exchangers for the market. But our heat exchangers weren't like your generic ones. We infused a technology called Vortex technology into our heat pumps. And this essentially helped cool air channel out from hot air, or vice versa. It could make hot air channel from cool air. And this new technology really increased our customer satisfaction dramatically. And as soon as our products hit the shelves, they were swept off immediately. It was almost like the demand for our products was higher than our supply. However, this also led to a large profit increase for us. And this led to us being able to match the supply, match the demand with our supply. And this also helped us compete with big companies bigger than us and punch much above our weight. However, as many of you know, the 2008-2009 fiscal year was a horrible year for most companies. The financial crisis crumbled the whole industry, and Vortex was affected by this as well. We had massive layoffs of staff cuts and profit loss, and sometimes we were going on a loss on the 2008-09 fiscal year. However, in hindsight, this was a blessing in disguise, as this caused a lot of our competition to shut down or divert resources to a separate project, leading us to be the main manufacturers of heat exchangers and gave us a monopoly over the market. Now you might think Vortex only survived with its staff and only helped its own individual company. However, the company's perseverance and focus led all of society through these hard times, as our heat pumps today are used in all your daily uses, such as refrigeration, ventilation, heating, and I'm sure as most of you here live in Malaysia, and with the heat, the most important one being air conditioning. So, let me remind you, just 1 year after the 2008-2009 financial crisis, we won an award in 2010 for the most advanced heat pumps, and this specific model to be accurate. But this shows our commitment and drive, even through tough times, to innovate and only be the best so that we can give our customers what they deserve. And this shows with this achievement. And furthermore, in 2010, when we won this award, we patented the technology. So we are the only ones who are able to use it. And since then, we've only been developing this technology and making it better. And I'm happy to say in 2023, our customer satisfaction is through the roof. And we have sold more products in 1 year than we have ever before. Moving on, Scott will present to you the background and the current state of our project.
Thank you, Nadev. So about the background, so first I'd like to mention about what is GWVPP. So GWVPP stands for Gravitational Water Vortex Power Plant. And it is a power plant that's based around utilizing the power of a vortex. Now, what is a vortex? It is whenever there's an opening in a body of water, the water will attempt to rush out the hole and create a vortex-like manner. So the way that a GWVPP works is that the flowing water in this vortex formation will push against the blade of a GWVPP, and this turning of the blade will help us generate energy. So back in 1930, Victor Schauberger discovered water vortex as a power source, right? And only in 2006 did the first GWVPP with a efficiency higher than 50% was created by Franz Zolleter. So where did we decide to build a GWVPP? We decided to build it in a river called Sungai Dinding. So, and this river, Sungai Dinding, why do we build it in this river? Is so that we can benefit a nearby village by the name of Thermalog, which is not just northeast to this river. So this is the river that the villagers use their afternoon time to fish in for like dinner, called Sungai Dinding. And this is Thermalog, which was founded in the 19th century, located in Perak. So I'm going to leave this to Chen to talk about the design and information of the GWVPP.
Thank you, Scott. Now I will talk about the design and specifications of the GWVPP. I'll be taking over our civil engineer's place here because he unfortunately cannot present today. Here is a rough model of what the GWB looks like. Note that this is just a rough concept and not the final design. Now we have a closer view of what the GWB looks like. Now here are these orange parts are actually holes where the water can enter the GWB, and these yellow parts are tubes where the water can come out. And the red parts is the floodgates. Now when the floodgates open, the water will come in and generate electricity. But if the current is too strong and might damage the turbine, we can close the floodgates to avoid damage. And now we have a side view of what the GWB looks like. That wooden board is a walkway for employees to walk by so they can look down into the GWB to check the situation and see if it needs maintenance or not. Now we have a closer view of what the turbine looks like. And the blade design we designed to use a curve. It's 16 degrees slanted. And the reason we use curved blades is because curved blades have a larger surface area. And more surface area means more pressure is applied to each blade, which means more electricity generated. As you can see from this graph, the more it's curved, the more electricity it generates. Now I'll be handing over to Bo, who will explain the suitability and maintenance of this GW.
Thank you, Chen. So I'll be talking about how suitable Sungai Gending is for GWVPP. First off, let's talk about the topography. The GWVPP, there needs to be a significant decline where water is taken in by the turbine and where it exits. Unfortunately, Sungai Gending naturally does not have this sort of decline. However, to solve this issue, as you could view in the design earlier, we're going to build an artificial dam that will create an incline about 2 meters in the beginning, and it will slowly go down, which will allow a decline that can fit, create the vortex in the GWVPP, which will allow it to generate power. Next up, let's talk about the soil stability. Of course, the soil in the river and beside the river have to be strong enough to be able to support the GWVPP and the dam that we're going to build around it. Unfortunately for us, the expert decision making for the location means that Sungai Gending has strong soil to support the GWVPP despite Perang being known for relative landslides in the area. Next up. Lastly, water flow and water level. Now, the GWVPP requires a certain limit, a minimum limit for the height and the flow rate of the river. Now, Sungai Gending, once again, fortunately, fulfills both of these requirements for the height and the flow rate of the river itself. Next, we'll be talking about some of the problems and solutions that GWVPP has and how we can solve them. The first issue we thought of is that fishes may accidentally flow into the GWVPP. And to solve this, we will be installing a wire mesh at the entry of the dam that will prevent fishes from going through and potentially damaging the turbines. Next up, GWVPP on their own aren't very efficient and they can't generate too much power on their own. So that's why, as you could do in the design earlier again, we will be installing 3 of them to generate as much power as possible. Fourth, the turbines may malfunction. So because of this, we will be doing monthly maintenance checks on the turbines through the walkway that will also be installed. We can check up on the turbines monthly. Lastly, the power plant is relatively far away from the nearest power grid and from thermal log. However, electricity can travel large distances without losing too much power. This problem is essentially wiped out before getting started. Thank you.
Moving on to the external problems and their following solutions. So firstly, we start off with deforestation. Now, Vortex is a company that's committed to being as sustainable and eco-friendly as possible. So we have pledged that for every tree that we uproot or cut down during the construction of the GWVPP, we have collaborated with an eco-sustainable company to plant 2 trees or twice as many trees for the ones we cut down within Perang. So our profile remains carbon neutral and carbon zero. Moving on, we have acknowledged the fact that locals might lose access to the river in the first few weeks of construction. Now, unlike most companies out there, Vortex cares about all individuals it affects during construction. And rather than pocketing our profit immediately, like most companies out there, we pledge to use our own profit to compensate these villagers in small portions if they were to lose their access to the river. However, we have also thought about this, and we have formed a small stream besides the GWVPP, or a tributary river for that matter, which would let water flow continuously and the marine life back downstream right next to thermal log. So they still would have access to the river. Moving on, we have unstable rivers during a flood or heavy rain. this is another problem that we've acknowledged, and we all know how bad the flooding and flash floods and how many deaths they've claimed in Malaysia. So we have thought about this, and we have built floodgates for both the GWVPP and this tributary river. So in this case, if it were to flood, our GWVPP would not be damaged, and we would close the floodgates of the GWVPP and open the separate stream in order for water to flow down, so that there's no clog upstream, which would eliminate any cause of flash floods or landslides, thus eliminating the problem totally.
Okay, so now I'm going to talk about the budget for the GWVP and how we use the 5 million ringgit if you invest in words. Alright, so the first, we decided to split it into 6 parts, and the first part is the GWVP itself, being the most expensive one, costing 2.5 million. And then the next one is the environmental cost, which costs around $120,000. And then the next one is workers. Note that we are hiring only one construction worker because our company itself already has some workers. And we plan to hire a more experienced construction worker to help manage and oversee the entire project with our lead construction manager, Tane. And it is accommodation for the workers to provide them comfort and rest so that they can continue working on GWVP. All the materials needed. Note that all of these are to be decided because during the process of building a GWVP, the amount may increase or decrease. However, it will not, the maximum amount that we will spend will not increase the second amount. And the value that we're using for our estimated cost is in the middle of these two values. And here are other costs, meals for the workers and deforestation. So estimated sum total is 4,200,000, around 4,800,000. But note that this value may also change. And this also means that we will earn a 760,000 ringgit profit, which means that a 15% return on investment.
So now, why should you choose and invest into Vortex? Now, by giving us the ability or the money to help Temelloh grow, the village will advance much faster than ever before. Why is this? It's because that when we can provide them with the energy, their education, their healthcare, and their standards of living will all improve. And it will likely lead that this village will turn into a land of opportunity for you to build your factories or your company headquarters at. And it is a really good location to be, considering that there is many roads that connect it to Temelloh. And by having a stronger education, we can implement more workers. There can be more workers from Temelloh that are well educated that can work for your company. This is our bibliography, and thank you for listening. And are there any questions?
Okay. That's fine. That's fine. Okay, thank you. Thank you. Wait. Oh, sorry. No.
Shit. Oh shit. Oh shit. Shit.
No, Windows. You minimize the Microsoft Inbox.
Test this. Is that?
Yeah. Oh yeah. Hi everyone. I'm from Sustainable Clean Senyas Berhad. In this PowerPoint, I will have a closer look at construction plan of the GWVPP. For this introduction, we will have a closer look at the company and experience, and also our team member. Sustainable Clean Senyas Berhad. It's founded in Malaysia in the year of
2010. This company provides all kinds of solutions to various industries, such as waste management to sustainable product developments. And for our company experience, we have won the Green Industry Award and also involved the project of a sustainable eco-tourism program in Sabah, Malaysia. The United Nations has also recognized the company for promoting sustainable tourism. And here is our team member that will provide all kinds of world-class service for our clients.
Now I'll explain, give you a brief history on GWVPP. Okay, the concept of a GWVPP was devised by Victor Strasberg, who was a forester and inventor from Austria. However, he never utilized his research and practices, ideas, but many years later, an Austrian researcher, Zoll Lotterer, attempted to use the first ever to use water vortices to generate electricity for the first time, and was successful in doing so. He made several changes in the traditional designs of a GWVPP, some of which I'll explain to you later. However, his design is now utilized in virtually every GWVPP today. Okay, first of all, what is a GWVPP? GWVPP, or also known as the Gravitational Water Vortex Power Plant, is a type of micro hydro vortex turbine system which is capable of converting energy in a moving fluid to rotational energy. It generates electricity via a water vortex and is widely used due to its eco-friendly and low carbon footprint. Then I'll explain to you advantages of GWVPP. First of all, it's eco-friendly. Secondly, as I mentioned before, it is eco-friendly. Easier to build and maintain is another advantage. And based on Bharacharya's introduction in 2020, GWVPP utilizes low-level heads and can be used in water bodies with low flow rates. I'll also explain to you the location of where we are planning to build this project. The GWVPP will be built beside Sungai Padang Terap in Kedah, surrounded by 4 hills nearby villages and towns, which numbers 570 households. The main form of economic activities in these places are farming, local craft, and eco sports. These places also have facilities like social centers, ranger offices, a clinic, and a primary school. This is a map of the Malay Peninsula, and the state which was highlighted in red, Kedah, is where the river is located. And this here shows where is the river. It's right at the corner.
Yeah, I know. Yeah. Yes. Does it? Sun? Oh, shit.
Okay, and this is just a simplified design of our GWBPP. We decided to build the GWBPP beside the river due to its low gradient. As you may see, they consist of all the basic elements of a GWBPP, like an inlet, a basin, if you look closely, a turbine, and a runway. I apologize about the lack of detail, but I'll explain to you about it. The basin we plan to build will have a conical base, and the orifice or the outlet will be maximized based on researches that explains how the efficiency is somewhat proportional to the diameter of the orifice. The turbines will be curved and slightly tilted between 15 degrees to 20 degrees to maximize the efficiency of the power plant. And following Zolotter's design, instead of a submerged orifice, we will use a free runway.
Okay. Next, we are going to talk about the cost of the GWBPP. So this table of budget. This is a table of budget that illustrates all the costs needed to build a GWBPP. So this project is expected to cost about like 5 million in total, including the operation costs after the construction. So I'm going to talk about the salary cost first. So salary costs, which includes payments to all workers required for constructing and the operation of the GWBPP, is like 285,600 ringgit. This requires, as a company, needs the manpower to build the power plant. Then the operator and the security will also be required to ensure that when we build the GWBPP, there's no one will disturb us. Next is the construction cost to which we need to build the GWBPP. We will need to pay for the land and foundation, the structure of the construction, mechanical, electrical, and plumbing, and other costs. It will cost about a 2,408,600, and there will be also the material and component costs, which includes a basin turbine, generator, electrical control unit, power cable, wooden fence and trap, UPCV pipe and CCTV and others. And it is like 1,708,600 ringgit. So okay, the ROI. So the ROI for our project will be like 9.78% by putting all the all the numbers into the formula at the bottom. We can get this percentage.
I will talk about the problem and solution for the problem and solution of the GWP. First thing is the GWP will be constructed in a frequently flooded area, so we need to build more flooding precaution constructions like higher flood zones and others. The river flow will also be unstable, so we will build batteries to act as backup electricity. So for the conclusion of I'll talk about the conclusion. Electricity need worldwide is on the rise. Government groups are also are anxious on keeping up with demands, also preventing damage being done to the environment. By using GWP as a power source, we can keep down the damage done to the environment while also producing more electricity. The construction of this GWP will benefit your company and bring in more consumer and profit. It also requires less maintenance and cost much in the long term. Any questions?
How can you boost your budget?
Huh?
How can you boost your budget? You're supposed to be spending 1 million, but you actually over.
I found this error and before the presentation, and he had already handed in the
Okay.
Half team. Kali mai. Share screen already or not? Check.
Subject 还没有。
Good afternoon, everyone. We are the board of directors from Degrees Industry, and today we will be presenting on our proposal to build a GWP to Persada Marine and Engineering Services Sedan Bahar.
Please, because every day you're very much.
First of all, let me introduce our company, Degrees Industry. First, which is me, the CEO of the Degrees Industry, and Yulia, the CFO of our company. And also Afuishin, our COO, is mainly help us to do our simulation work. And also Jaden, one of our senior engineer, and also one of our senior engineers.
So to in this proposal, we'll be going over what is a GWPP, our implementation, our technical information, the design of the power plant, its suitability and maintenance, our proposed budget, problem and solutions, and finally our conclusion. So a GWPPP is a new form of renewable energy that was first developed in Obergrenfendorf in Austria, and it generates power by the movement of water through gravity in a dome-shaped bowl where a vortex will be formed, which then turns the turbines. So our project budget will be 5 million, and the work duration will be from June to September, which is approximately 4 months. And the location will be in Sungai Tahan in Pahang, which is located in Taman Negara and a secondary tributary of Sungai Pahang. And expected outcome will be to provide renewable electricity to 250 households, 1 clinic, and 1 community center near Sungai Tahan. So here is our implementation which will be presented by Keith.
So I'll be talking about the implementation. So in June 2023, during the week 1, we will request permission from the Department of Wildlife and National Parks to use the Taman Negara for our GWVPP. So during the week 2, we will interview subcontractors for workers and the architects. During the week 4, we will begin construction of the 2 GWVPPs. And in July 2023, during the week 1, the compound of the GWVPP will be built. During week 2, the river diversion canal will be built as well. In August 2023, during the week 1, the power grid will be installed in the community. In September 2023, during the week 1, the turbine and the components are installed, and the electricity lines and components are also installed. During week 3, we'll be testing our turbines to make sure that it works well. During week 4 will be our opening ceremony.
And now it will be the simulation of our GWPP, which was done by our COO, Ng Wei Xuan.
Our GWPP simulation will be able to let you understand a better understanding of what are we going to do and a better image. The water flow in is where the start of the river flow. From this part, it will flow and then it will enter into the input, in the outlet, and the debris filter. And the debris filter will filter out larger objects, which prevents such as wood log or tree log to entering our canal and will cause our GWPPP, the turbine start, and unable to work properly. This is the upper view of it, and this is the current of water flow where from left to right, and it will enter from the river diversion cooler, and this is our turbine and our generator, and transformer will be stored inside a specific place, enclosed area, to prevent bad weather and other physical damages our generator. And this is a zoom in of our turbine. And this turbine is designed fish friendly to prevent smaller fishes from entering and get hurt and injured while killing them. So, and our turbine is used with less weight material, such as similar to aluminium, in order to able to spin easily and generate more electricity.
And also, our turbine will be housed in a dome-shaped housing where water will be able to flow in a more efficient way, and our blades are angled at 60 degrees with 4 blades on the turbine.
And this is a side view of it, and the water flows out from that part, and we have a higher region and lower region. The river flow from higher region to lower region because higher region will have higher gravitational potential energy. Hence, the water current will flow faster, and it will push the turbines more and faster to produce more electricity. We want efficient, simple, and durable.
And now here is our technical information.
So for technical information of our GWVPP, our impeller diameter will be 1.9 meters. Our hydraulic output will be 78 kilowatts. Our electrical output will be 70 kilowatts. Our maximum energy generated per year is 610,000 kilowatts per hour. Our dimensional core will be 1.8 meters times 2.1 meters times 2.1 meters. Our impeller and support weight is 870 kilograms. Our generator and gearbox weight is 1,070 kilograms. And in total, our core weight will be 1,940 kilograms.
And now we will go on to our proposed budget, which will be presented by our CFO, Yu Yang.
So for our proposed budget, we'll have 5 million budget and it's separated into 4 different sections: construction, expenses, consultant, and manpower. So for construction, the construction of 2 GWBPP will cost approximately 2 million, and 2 converters will cost around 66,000 ringgit, and the excavator will cost around 19,200. And for the expenses, we will provide food and hostel for the workers, and we will require highlights to transport manpower into the hill, and we'll have banner for our opening ceremony. We also bought extra spare parts in case of any malfunction of the generator, and wiring and power line supplied to all of the households and clinic and community center of the location. We also just install CCTV and application software to make sure everything is working, and we will have water level monitoring indicator and water quality monitoring indicator to solve some of the issues that will be mentioned later on. So for the manpower, we will hire 2 external architects, which will cost 100,000, and 2 external supervisors to supervise and monitor the work progress by the construction worker. And we will also hire 3 electricians, which costs around 80,000, and 2 drivers of the excavator. So for the consultant, we'll have a lawyer. To do our permits and legal fees, and our environmental consultant to deal with the impact of the construction towards the animals and habitat near the location.
Therefore, the total expenses of our project were approximately 4.6 million, and the miscellaneous fund will be 0.6 million for emergency purposes. And this will be the financial projection of our company. In fiscal year 23, we will have a revenue of 224,250 ringgit. And the expenses for 480,000 is for the employees of the 48,000 of our employees from the local community, as we hope to support the local community to provide more opportunities as we build the GWBP at the location. Therefore, we have a profit approximately of 176,250 ringgit, which the returns on investment of fiscal year 23 will be 3.5%. And also for the fiscal year of year 24, the revenue will be 269,100 ringgit, and expenses will be the same as we just employing 2 employees from the local community, and the expenses will be 48,000, and the profit will be 251,100 ringgit. And the return on investment of fiscal year 24 will be 4.422% for our project. Next.
So for the entire construction of the project, it will cost approximately around 4.6 million, and the remaining 400,000 will serve as a miscellaneous fund for the entire construction. If any problem or we face any issues, we will have to spend the remaining money to solve the issues to ensure the proper and smooth functioning of the GWBP.
And for the suitabilities and the maintenance, we have calculated for when the residents of the nearby the River Taha, they are using the oil generator, which will generate 755.89 kilogram of carbon emission. However, if they use the electricity provided by the GWBP, the carbon emission will be 0. And our blade also, as mentioned by Vincent, our blade also special design for the fish, as we hope to the fish as we build the GWBP, because there's Taman Negara, there's important animals, and so we hope them. And the regular system inspection will be done by our 2 employees, as I referred before. before. And we also will provide the education opportunity for the local university students and let them to have the exposed to the advanced technology and green energy.
Okay, so for the problems and solution, so one of the first problem that we'll be facing is we don't have a proper route set up in the location. So therefore, we will use off-road vehicles like pilots to transport manpower and materials and lorries. And the second problem is there might not be a proper source of electricity at the start of the project, as we will have to bring our own power generator until we finish construction. And soil instability, which is a very crucial factor as most of the construction will be near the soil, and we will manage the water flow and monitor the water flow using the water monitoring indicator. And for the impact on wildlife, we will conduct wildlife management with the environmentalists that we have mentioned just now, as we will try to not impact and harm most of the habitat.
And now in conclusion, our GWPPP uses a turbine to produce energy from the river's natural water flow in an eco-friendly and low-carbon natural manner. And to safeguard the environment, it will also promote ecotourism and give the locals around the river access to clean and affordable electricity. It also contains free safe turbines to ensure that no species of fish will be harmed, as they might get through the debris gate and into the turbine. It will also offer a dependable source of electricity to support everyday operations of ecotourism and assist in reducing power outages in the area. It will also provide a learning site for engineering students and anyone who is interested. And also help to give Persada Marine a better name in the green industry. And thank you. And are there any questions? And here's our reference list. Okay.